Okay, so I'll explain the finding zeros of polynomials topic that's assigned to you guys Khan Academy profiles right now. So when you're looking at a polynomial and trying to find the zeros, basically what we're doing is we're trying to look at all possible values for x that would cause this overall function right here at p to equal 0. So what is it that I could plug in for x here, 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 and here that would cause all of this to equal 0 in the end? That's what we mean by trying to find zeros. So the best and easiest way to do that is to factor all this down. And so to get it all into factored form so that we can see individual pieces that only have one x with an exponent of 1. Okay, so first off the bat, let's see if we can get anything easy factored out of here. And so I see something easy that we can do, and you can always check for this, that we've got an x to the fifth, x to the fourth, x to the second, and an x. So each one of those terms has an x in it. So we can go ahead and factor out an x right at the very beginning. So we're going to have the same thing here, but we've basically undistributed an x. So we're going to have 3x raised to the 4 now, because we've taken away an x. So it used to be 3x to the 5, now we only have it 3x to the 4th power. So that actually goes down the list. Each one of these is going to lose an x out of their exponent category. So this will be 10x to the 3rd. This over here will be 21 just regular x. Sorry, 21x. And then we'll have a plus 70 with no x. Okay, so 3x to the 4, 10x cubed, 21x plus 70. Okay. Here's an example of an equation you might need to use factor by grouping on. So factor by grouping is where I take, I'm trying to factor this 4th degree polynomial, and I don't see anything really obvious that I can factor out just from all of them. So I'm going to have to take 2 pieces at a time and factor those. Okay, so what I'm going to do is I'm going to grab, I'll change colors here. Potentially help you see this a little better. Okay, so I'm going to take these right here, the 3x to the 4th power, and the x to the 10th, 10x to the 3rd power, and I'm going to group that. I'm going to take that as a grouping. All right, and then I'm going to, let's do that over here, where I have 3x to the 4th power, and I have minus 10x to the 3rd power. Okay, well now we've got some things that we can take out. So they all have x's in them. This has a total of 4 x's. The 3 term has a total of 4 x's. 3x to the 4, there's 4 of them in there. And 10x to the 3rd, there's 3 x's in there. All right, so what we can do is we can factor out an x to the 3rd. So let's undistribute that. And so now what we'll have left over is we'll have just 3x by itself, and we'll have minus 10 by itself. Okay. Cool. So now we've taken care of that. That's the red category. That's the red grouping. Now let's go in green over here, and let's take care of a different grouping over here. We're going to factor this out. And this will be negative 21x plus 70. All right, so there's something we can get out of that. If we notice, 21 and 70 both have a common factor of 3. We actually also have a common factor of 7. And what we should do is try to see what we can do to match the inside over here. We should get something so that we match our 3x minus 10. So if we we take out a -7, if we undistribute a -7, that'll give us a positive 3x minus 10. And if we distribute that back, distribute the -7 back in, we get our -21x. We distribute the -7 back in, we get a 70. Okay, so we got that right, and now we're on to something, because we've found out that we can put these two together, and we can say x cubed minus 7, because those are the two things that we factored out. And then that left us, when we did that process, that left us with 3x minus 10 in both cases. So that's how we know that that's the factoring behind this giant fourth degree polynomial that we grouped in the red brackets and the green brackets. So knowing that, now we have significantly narrowed down the playing field here, because remember we found out that there was an x at the very beginning. See this this x over here, that was taken out at the very beginning. So what we're up to now is that we found the x cubed minus 7, 3x minus 10, and x are all gonna be the factors of this polynomial that we did. Okay, so what we know now is that x cubed minus 7 equals 0, and if we solve for that, we'll find one of our zeros of x. We'll find one of those x values that gives us 0 in the equation. Because when we multiply any of these three pieces, and if any of those three pieces are 0 when we multiply them, we'll get, the whole thing will be 0. The whole equation will be 0. So we're just going to set each one of these pieces equal to 0, and that's going to basically tell us what value of x could cause this equation to be 0. So, all right. So, and over here we got a nice freebie over here. We already know that x is equal to 0. All right. We're setting each one of them equal to 0. So, right off the bat, that helps us with an answer here. We'll give it green. So that's one of our answers. X equals 0. Whenever x is 0, the whole thing can be 0. You'll see that quite a lot. For the rest of them, we'll need to do a little solving. So we're going to add 10 to both sides of this equation, and we'll come up with x equals 10 over 3, because we'll then divide by 3 on both sides to get the x by itself. So y'all can handle that. Over here, we're going to add 7 to both sides, so we'll have x cubed equals 7, and if we found the cubed root of both sides, we would find x would be the cube of 7, or the cube root of 7. Okay, cool. So that could very well be possible. So we would have three things here. We would need that number to stay positive. So whatever that is. I mean, let's see. We could even find a calculator. Tell what that would be. And cube root of 7 is like a decimal. Of course, it's like 1.19 or 1.91. But we would know that it'd be positive because cube roots yield positive numbers. It's fine. Over here, we know that 10 over 3 is just a regular old number. And, of course, x equals 0. So we've got three possibilities here. I solved all of this out all the way just to make sure that none of them were i's or anything, because that wouldn't be a real number. If we got I as any of our answers, that wouldn't be real. So it wouldn't count, but right now we've got 3. So we know what our roots are. Here they are. We found out what they are. There's 3 of them. And it wants to also know what's the largest real root. Okay, so out of these 3, we found out that our answer for the cube root of 7 is actually 1.91. For those of you who like to transfer to kind of our number line system. Over here, if we look at 10 over 3, that'd be 3.3. So x equals 3.3. So that looks like our largest real root right here. And so let's just put 10 over 3 in there. All right, and so we've got whatever the question was asking. Oops. The question here was asking, let's just make sure we get everything. How many distinct real number roots do we have? And we found that we've got 3 of them, because we didn't have any i's. And which the largest of these 3? And we found out that was 10 over 3. All right, cool. Okay, if you'd like to stick around for another example, I'm just going to do another factor by grouping example. We'll see if we get anything that looks a little different. So right off the bat here, let's set up our 2 pieces that we're going to group. I'll do red and blue this time. All right, so we got x cubed minus 7x squared. So let's go back to red. X cubed minus 7x squared. And what we can factor out here is an x squared because they both have that term. So that'll leave us with an x minus 7 in here. So let's go factor the blue side and see if we can get that to happen in the same way. Looks like we're going to have to factor out an 8 because that'll leave us with x, which is what we want. And we'll have to factor, and when we do that, that'll leave us with a negative 7. So that works. That's what we want. And you'll see that working like that. That's going to be the way these problems will work. So what we're going to have as our, what we're going to have, well, we're just going to stay blue. What we're going to have right now is x squared plus 8, because we factored out positive 8 over here. And we'll multiply that with x minus 7, which is what we found out a second ago. So, and then of course, after this red and the blue business, we've got an x minus 7. So all along, we had that in our equation as well. So x minus 7 will also be here. So this is about as factored out as we can get. So let's take what we got. So we got 2 pieces here that are repeats of each other. So we know that if we set x minus 7 equal to 0, we'll add 7 to both sides, and we'll get x equals positive 7. That goes for both of them since that's a repeat. All right, so we know x is positive 7 in one of our cases. And on the other side, we're going to have to say x squared plus 8 equals 0. Now we subtract 8 from both sides and we square root 8, and we'll just get a radical, which is the square root of 8. But what I want to show you here is that when we take x squared equals negative 8, which is what we're going to get when we solve this equation, is try to square root both sides, we're going to be square rooting a negative number. And that's not something we can do. So we're going to have x equals I, the square root of 8. So we're going to have an imaginary number in one of our roots. And what it's saying is how many times does it intersect the x-axis, which is saying how many real number roots do we have. Now, what we found out over here, oh, there's my colors. All right. What we found out over here is that one of our real roots is 7. So that's one time that it's crossing the x-axis. We found a root over here, but this one's an imaginary number, so that one doesn't count. So we are not going to say 2 roots. We're going to only say 1 root because that's the only real number, which is the only place where that actually crosses the x-axis. And the largest of these would be 7, 0. That would be the point where that happens. Okay.